to this point, we have read a single ADC sample. What we'd like to do is get regular samples so that we can graph them and see the responsiveness of our ADC and that everything is working as expected. So, the first thing we need to do, to do this in a very rough way, is to add a delay, and later we'll add a timer and move to interrupt-based solution. But for now, we'll start with delays. So going back to Atmel START, adding a delay driver and simply exporting the project, downloading a pack, coming back to Studio, reconfiguring the START project, browsing to the new file, adding it, leaving main unchecked as before because we will keep what we've done in main. But now in Atmel Start.c we should have a delay example, and that's what we're going to do. So let's start with delay of 500 milliseconds. So we'll start with every half second readings. So what are we going to do? Every half second we'd like to start an ADC conversion. So we'll leave that initial conversion there and start conversions here. And then what we want to do is wait for conversion complete while, okay, and let's copy this, and we're just going to wait here and do nothing. So this conversion, we're going to define it as volatile, so it's not compiled out of our project, and give it an initial value of false. And when will it be done is when we come to the call conversion complete callback. So here our conversion is done, so we can set this to true. So once our conversion is done, the thing that we can do now is try and read the ADC. So how would we find functions to read the ADC? Hel, source, and here is the ADC asynchronous C file. So this is basically our driver file for the ADC. And looking here for a number of functions, we can see that there's an ADC read function. Read data from the ADC. So we can copy this and we will read. So there's a number of different variable types it needs to take as parameters. Struct ADC asynchronous descriptor. So let's look at some of the other ADC functions. And we can see that they also take the struct ADC descriptor pointer. So that's what I'm going to do here, is just copy that same thing. And it makes sense because we're talking to the same ADC hardware module. Now we'll need a constant pointer to a buffer. Now we set up an ADC, so we want an ADC result, and we are going to send a pointer to this ADC result variable, which we will set up, and length 1 because, hey, it's an 8-bit value. So we need to define this, and remember it is a uint8 type. Type, and that's our ADC result. So a little note, C defines or treats arrays and pointers in the same way. So if we had ADC result 2, which we'll do later on, then we wouldn't need the ampersand here. Anyway, so we have now read the ADC, and let's put out a value from our ADC. So we use our IOWrite function and just send exactly the same thing here, pointer to the ADC result, and that's simply 1. Okay, now let's compile and see if we can see some results. So that was on the screen from before. Okay, and then we don't see anything, and then we see some rubbish, because what we are actually reading is hex values now. So if we enable hex values, we can see that we have some valid values changing as I touch the light sensor. And if I now add a graph, and I would need to add a plot, and take the same and plug it in here, and now you can see that. And now once I have the range up, I can uncheck this so that it stays in that same range. And now you can see that my ADC is updating, and I am both getting hex values out as well as graphing this.